Sorry I missed on Friday. I was a little busy at work last week. So, yeah, only announcements I have are that the projects are due in, is it less than 2 weeks? Less than 2 weeks. So, no, is it?
3 weeks if you count.
I guess we have 3 weeks. We have until December 4th, which is 2 to 3 weeks away. So I'm anxious to see milestones this week. On Friday I'll definitely be here. So yeah, any questions from folks? Concerns? Are the projects you chose too big? Too small? You're already finished? No? Okay. So today we're going to do a little bit of a core data recap. So for me, I think when Colin presented it, I'd say for many of you that was probably the first time you saw core data. For some of you, maybe not. For me, that was also essentially the first time I sat down and had anyone actually tell me about it. So what I've been trying to do is, spend a little time to learn it as well. So I'll present as much as I can today. I only got to a certain point in terms of me learning it. So hopefully some of what I've learned will actually help you. And then probably what will end up happening is on Friday, we'll finish up with it and also include key value coding and key value observing, which is something you may have seen in the documentation while poking around through various things. That stuff's interesting because it's sort of how, well, some of the things that seem like magic with core data are because of key value observing and key value coding. And it's also how some of the interface builder stuff happens behind the scenes. So we'll look at that on Friday, and maybe the accelerometer, because we'll have, like, the things we have are sort of smaller now, little chunks of things. Okay, so core data recap. So what is it again? Does anyone vaguely remember or have some thoughts as to what it is? Some opinions? Yes.
Is there a place where you can store your data that's in like a file system, sort of?
Okay, so yes, that is part of it. So it's so you can think of it as a place where you can store stuff. So that's like a piece of it. So core data itself is this API that lets you manage. Well, it lets you manage your models in some way. So we've talked about the model view controller pattern a number of times, and we've seen that the views come from the interface builder world, and then sort of the controllers and the models are things that we've been working on ourselves in code. So core data and some of the tools that it provides gives us the M part of the model view controller pattern stuff that we've been using, and it provides some tools that help us create these models in a nice visual way, and then it basically, core data itself is a set of APIs and objects that basically allow us to save data in certain ways. So we can either the data we store doesn't necessarily have to be stored to a file. It can actually be in memory, in which case it's, unless your machine never turns off, I guess it's not really persistent, but that is an option. So let's see what I've got here, and we'll sort of see how to use it as we go through. So when talking about core data, basically, usually we refer to this core data stack, and these are these objects that that work together to read and write data to some sort of storage. So that storage could be file storage, could be a database, could be memory. In general, when people are working with it on the iPhone, it tends to be, like, the store tends to be an SQLite database, but it doesn't have to be. So I feel like I'm doing this backwards because I have some slides towards the end that talk about modeling, but we'll go through it this way and then we'll sort of back up again, and hopefully we'll have a clear picture of what core data actually is. I guess before I go in, I'll step back and just say, in general, the way to think about it is core data gives you some sort of abstraction to stuff that you want to store. And generally what happens is through the APIs that they provide, when you reach into that store and pull things out, you get them in a way that you're used to using them, which is through objects. So, you've created your own models already where you've got various properties on them. So, there's a person model, and its person has a name and a social security number and various other attributes. So core data helps take care of storing that stuff in some way and then retrieving it efficiently to display, to interact with in some way. So generally when talking about core data, we refer to, yes?
So for those of us who are familiar with object relational mappers, is core data really any more than just an object relational mapper with some associated visual tools?
Right. So I'm also familiar with object relational mapping. So for those of you who've used Ruby on Rails, for example, Ruby on Rails provides something called active record, which is this abstraction, this ORM abstraction over your database. So what happens is, if for whatever reason you want to use a MySQL database as the backend, you can do that. If you want to use Oracle's, whatever, that doesn't really matter to you when you're actually interacting with your database, because what you end up getting are just these objects that you interact with. And core data does provide that. I haven't used it enough yet to really know whether it gives you much more than that. But in general, the way to, and we'll look at it when I talk about modeling, but the general way to think about what's going on with core data, when you're creating these things called entities, these entities tend to be tables, and these tables have cells or have columns, and these columns represent various properties. And then the rows in these tables represent instances of objects from your store. So in that regard, yes, it is. But the thing that bugs me is that in none of the documentation that I've seen so far has Apple actually referred to it as an ORM. So it makes me feel like there's something more there. And I think the something more that could be there has to do with this idea of bindings, and so key value coding, which we haven't discussed, and key value observing. So I'll just mention them briefly right now, just because I did want to talk about it today, but I didn't think I'd have time, but I'll talk about it. So key value coding basically is a mechanism where you can access instance variables of your model classes via string. So normally you have your model object and you say, hey, model object dot whatever my property is. Instead you could say whatever my object is, value for key, and in a string, property name, whatever the property name is. So that's the first piece. So basically you can get inside of your objects by just poking them with some strings. And the other part, so you can get inside your objects by sending in some strings, and you can access these instance variables even if properties haven't been created. So we've been setting up these at properties, retain stuff. Even if you don't set those up, you'd still be able to access them. The other piece of it, and again, I haven't used this stuff very much at all, really. But the other piece of key value coding is key value observing. So what happens is you can set things up so that when data changes in some place, you will be notified of that having happened in some other place. So that could be useful if you have a lot of views and they're all sort of poking into one model, and based on whatever happens, you want these various views to change. So in a way to minimize the coupling between all of these objects, key value observing facilitates this stuff. So I would say that's how it's different from a traditional ORM, in that when you access or modify something, there are some notifications and things that happen in the background. That's my first guess at it. So if you find something else about it, I'd love to know. Okay, so usually when talking about core data, we refer to a core data stack. And so these are just the objects that work together to read and write data to some storage. And so this I pulled right out of Apple's documentation. This is a representation of the core data stack. So At the very bottom, we have this store file, and then moving up, we have persistent object store, so a collection of object data, persistent store coordinator, a collection of stores, and then off to the right, there's this managed object model, which people like to call MOM. And then at the very top, there's this managed object context. So let's go through each of those and say something about them and see what we can learn. So the persistent object store manages storage. So I mentioned earlier that the storage doesn't necessarily have to be a file, but it could be. So it would manage the opening and closing of these files, or setting up whatever it needs to set up, allocating the memory that you might be utilizing. The other thing that it does is it takes care of this mapping between data in the store and objects in the managed object context. So we'll look at what the managed object context is in a little bit, but basically if we look here at the very bottom, so things sort of, they'll kind of move up and down this stack as you interact with things. And at the lowest level, you can imagine that the persistent object store at some point has some sort of information that is your object's representation. And in order to get your object and shove it into an SQLite database, for example, or into some other sort of binary file, this persistent object store, which is very specific to, say, SQLite, will take your objects and transform them into some sort of data that SQL can utilize, for example. Yes?
So it's a collection of converters?
I would say the persistent store coordinator is more, would be more of a collection of them. The persistent object store itself, as far as I understand it, tends to be very specific to a particular type of storage, for example, SQLite. And we'll see I have another picture somewhere towards the end that maybe makes that a little more clear. So this persistent object store, there could be multiple persistent object stores, and they would be all managed by the persistent store coordinator. On the iPhone, generally, you will generally just have just one, and it'll tend to be an SQLite backed object store. So in terms of the persistent object store itself, your interaction with it is fairly minimal, as far as I understand it, besides just creating it. You're pretty much kind of, you've created it, you've set it up, and there it is. And as far as the iPhone is concerned, you have the type of storage that you can have is SQLite, so a SQLite database. There's some sort of binary representation, and then you can also, if you wanted to, you could use memory to do various things. So utilizing, the main memory for this, it's definitely doable. It probably would be a situation where you have, a number of objects, but they don't take up a lot of space, and just the interaction that core data gives you, the ease with which you can bring data in and out and manipulate it, it might make sense to do that. Okay, so next up, the persistent store coordinator. So that sits between these managed object context and the persistent object store. And basically, it's a generalized interface to the persistent object store. So like the question that was asked a little bit ago, basically, as you go lower in this stack towards the persistent object store, things start to get more specific. So as you move up to the persistent store coordinator, it's much more of a generic interface to, between your model, your managed objects, and the persistent stores. And if we look off to the right of the persistent store coordinator, there is it has this information about the managed object model. So the model is just, the models that you're used to using, these objects that have properties and whatever various bits about them. And as far as, we'll look at the managed object model shortly, but basically the persistent store coordinator uses these descriptions to facilitate the movement of information up and down this stack. So the managed object model, like I just mentioned, basically the description of your model, properties. We have a person model, and the person has name and birth date and various other things that you can think up. And next up, the managed object context. So this one's at the very top of our stack there. And the thing just says here, it's a collection of managed objects. So what happens here, the way the documentation likes to refer to it is, they say that it is an intelligent scratch pad. So what happens is when you query, when you need objects from your persistent store, basically they'll come into the managed object context, and they'll just be hanging out there, and you can poke at them and do whatever you want to them, and they're just hanging out there, and they're temporary, and you can modify them in whatever ways you want to modify them. And if you don't save them, then your persistent store hasn't been modified in any way. So in order to actually get that stuff saved off, you have to actually tell them to go ahead and save. So basically all of this is just this abstraction, these layers of abstraction that eventually get you these model objects that you can interact with. And it seems kind of wacky at first, but I think the more I'm looking at it, the more I'm like, oh, this is pretty nice, and I'm looking forward to using it for something in the near future. But yeah, so managed object context. So another diagram I found in the documentation that just sort of kind of a higher level, another look at all of this. So we have our managed object context up top, and we have, in this case, we have a few of them, and they link up to some persistent store coordinator. And in this case, we see the persistent store coordinator has 2 persistent object stores. So again, on the iPhone, you probably will not have more than one, but in this case, I think their image would have been more interesting if instead of one of them would have been file, and one of them would have been like database or something. Because what'll end up happening is you can take all these things from different persistent object stores and sort of merge them all into the model that you will interact with. So even though they're stored off separately, you can actually sort of glob them all together and work with them. So let's see. I think. Actually, okay, so let's take a look at how this core data stack is built. And the way we'll do that is, we'll just look at the sample, at the templates that Xcode creates for us. And we'll walk through as much of that as I have sort of annotated, and maybe we can try and figure out some other stuff too for folks who have used it more in depth. Yeah. So basically, this particular project that I have, I won't create another one, but basically it's just a navigation-based application, and make sure that in this case you check that you want to use core data for storage, just so that it sets up a bunch more things for you. You can do it yourself. It's just why when Xcode can do it for you. Oops. So if we take a look at our app delegate, usually when things get set up, let's see here, try and get everything on screen. Usually, I guess some things will get cut off. What we're used to seeing is that we'll have this stuff sort of put in there for us by the template. Now we've got a few other things in here. So, managed object model, MOM. We briefly talked about that. There's a managed object context, and then there's some sort of persistent store coordinator. So basically they've thrown in the things we need to make our core data stack. And if we look down below, we see a number of properties to access, those stack elements. So let's see here. So let's look at constructing this. Okay, so in terms of actually constructing, building the persistent store coordinator. So this was that thing I mentioned that we wouldn't interact with very often, but you pretty much set it up and then you're done. So what's going on here? Basically, we're getting a path to some file, core data movie.sql, or core data move. It was supposed to be movie when I wrote this, but so basically we're saying, here's the path, or here's the path and name of the file that we want to store stuff into. And when you generate the template, you can look yourself, but well, I guess we can just jump there. So the applications document directory, it just does just some stuff to help find the document directory. And I think last time when we talked, if you remember, when you want to save something, when your application wants to save data, you want to save that data to that documents directory inside its little application bundle that gets set up. And you want to do that because, well, first of all, that's sort of one of the few places that you can write. And it's the place where when the user does a sync and does whatever backups they do with iTunes, stuff from that documents directory will get pulled over. All right, so this is the name of our file, and it's going in some particular place. And next up, we just say, okay, let's take our persistent store, allocate it, and initialize it with some sort of managed object model. And we'll look at that one shortly. But it's basically, it's like, hey, let's set up some pointers. And remember, right, the managed object model is this description of your entities and sort of how your objects relate to each other. So we initialize it, and that's pretty much it. You probably want to do some of this stuff, but for now, for us, that's good enough. So let's take a look at, should be the managed object model. And let's see how that gets set up. So again, this, the code's pretty short for this. It's basically, okay, NS managed object model. Well, so if it hasn't been created, then go ahead and create it. NS managed object model, and then merged model from bundles. So what this will do is it'll look through all your application directories and look for these moms, and basically glob them all together and stick them into this one managed object model. So yeah, I think during the compile, I think that the models that you create will be placed in this mom file, but I'm not 100% certain. But that should be what happens, because when it starts searching for these, it's got to search for something, and I think that's what it is. So we've created the managed object model. So far, we're basically right. We set up the persistent object store. We've set up this managed object model. So at some point, we're probably going to have to set up this persistent store coordinator. And let's see if that is next. I'm sorry, that part came in for us. Next up is the actual managed object context. So in terms of the managed object context, well, actually we left out the persistent store coordinator. So at this point, we're going to go ahead and create our persistent store coordinator. And and our managed object context, and we're going to assign the managed object context the coordinator that we just created. So the one thing I wanted to see that I'm missing is the part where we actually tell it, yeah, sorry, I went a little too fast through the persistent store. Wait, actually no. Okay, let me back up and start again. So I was thinking we were at the persistent object store, which we are, but it was also setting up the persistent store coordinator at the very beginning. So again, we find our file, we set up our persistent store coordinator, and we, give it this managed object model, which if we go in there, it's some other setup that's happening. The thing that is interesting, or the next little useful bit, is the place where we actually tell it, hey, here's how we're actually setting up our persistent store. So persistent store coordinator, add persistent store with type and SQLite. So this is where we're telling, we're sort of saying here's the type of thing we've chosen to use. So as usual, right, option, double click on there, and we should see some information. So we'll see that, if we wanted to, we could use an NS binary store type or NS in-memory type, if that was the right thing to do for your application. So, all right, let's see. I think that's all I wanted to look at in here. So that stuff's all kind of generic boilerplate stuff. It's just important to know that in order to create this stack, you need your persistent object store and the store coordinator and the managed object context. And from there, let's see. Well, so let's see. Let's take a look at how we actually model the objects. So we saw how to build up the stack. In terms of actually modeling, so I mentioned this briefly at the beginning. I'll mention it again. So you'll see the words, you'll see the word entities thrown around. In general, entities will correspond to some sort of a table, and these tables, these tables have columns, and those columns will represent properties of your objects, and then the objects, the instances of your objects end up being rows in this table. So imagine a table of person objects. So a person has a name and a birth date, and all of us are people, and we're in this person's table. So if we wanted to get data about me, we could query this table, and it would find the row with the name Serban, and bundle that up into some sort of object that you could now work with, and you could say, oh, what's Serban's birth date, or what's his social security number, or whatever. So that's sort of a very high level way that, again, I don't think it's necessarily the way that, I don't remember if I saw Apple describe it this way, but this is more of the object relational mapping sort of way of thinking about what's happening in modeling your data. But so, in terms of actually doing the modeling, when you select that, when you click that checkbox for core data, you'll end up having some sort of model file in your resources, and usually it'll have like one little thing in there, but I've already gone and done some work in it. So let me zoom in a bit, and hopefully that's a little better. So the idea is in here, so I was thinking of setting up something where there's a theater there's a theater model, and theaters have movies associated with them. So then there's some sort of movie model, and that's what I was setting up here. So I'll push these aside, and I'll just make some new ones, and I won't save them, just to see how I set up this particular thing. So if you look over in the upper left corner, you'll see your entity. That's kind of your entity area. So let's create a new one, and we'll just call it Theater 2. And once you set it up, theaters have some sort of properties or associated with them, so you can head over to this other section and add some sort of attribute. So the attribute is your property. So let's say that, we'll say the theater has a name. We'll just do the same as what I did in the other ones. And we'll set its type to be one of these things. Let's say it's a string. And then you can do some other things, some other fancy things with the attribute. You can set up some sort of regular expression on them, a default value, minimum, maximum length. This optional thing, I don't have a good grasp of exactly what it is, but the basic gist of what I've seen is that generally you don't want these things to be optional, and when they're not optional, it helps. Maybe I shouldn't say too much about them, since I'm not 100% sure what the best way of using that is. But the things that I have seen mention that generally you want to unclick optional, because it somehow helps with the integrity of your objects. So for now, we'll just say non-optional and look through the documentation at some point to figure out what exactly that's all about. So we've got a theater, and it's got a name, and I don't know, what else do theaters have? We'll say that they have today's date, and there is like a date field that we could use in here, but I'll just go ahead and use string, just to use string again. So we've got our theater. Let's make another movie model, or another movie entity. So movie 2, and again, our movie might have some sort of name, same sort of stuff. And maybe there's some sort of description for the movie. And we'll just leave it at that for right now. So what happens is we now have, we have a theater model, and we have a movie object and a movie model, or we have these entities. What we haven't really discussed or set up is how these two things relate to each other. So, if you look closer, farther down here, we'll see, right, we've got our attributes, so we've taken care of those, and we have some sort of relationships. So what we can do is we can say, well, we know that theaters tend to play more than one movie. So a theater has many movies in general. And for the sake of this example, we'll say that the theater is the theater at my house, and so that, basically, my theater has many movies, but my movies belong in only one theater, which is my house. So what we can do is, again, while on the theater model, we can, instead of adding an attribute, we can add a relationship. And in this case, we'll call the relationship movies. And again, we'll get rid of this optional thing. And if we look, I'm not sure how legible or how easy it is to see there, but we have a few of these other, there are a few other options. So first off, there's destination. So what this is, this is basically where we're saying, let's link up one entity to another. So our theater 2 has many movie 2s, so we'll go ahead and set that up. And if we zoom out, we'll see that, it created this little arrow to it. And as I mentioned earlier, a theater can have many movies, so that is this idea of a too many relationship. So an object maps to many other objects. So we can click that, and as soon as you do that, you will notice that the arrow has now become this double arrow. And one last thing that we want to do is take care of this delete rule. So if this object is destroyed, how do we want to proceed? And right now it just says nullify, which basically, well, it won't do anything to any of its objects in the relationship. So what we want to do, say we want to delete everything, we want to do this cascade option. So with cascade, will if you delete the theater, it will also remove movies. So let's set things up in the other direction, because a movie has a theater associated with it. And so let's select the movie and add a relationship for it, and we'll call that one theater. And its destination we'll say is this theater 2. So now we have these double arrow things going around, and some of the stuff I saw in the documentation, they suggested that in general you want to make sure that you have these inverse relationships set up, and I think part of that has to do with just the efficiency of doing various queries on these objects. So the idea is if well, in general, I think if you can map from one object to another, you'd like to be able to map back the other way. So in this case, we can again say that let's map back, in this case, to movies. And once we do that, those two lines they become one, and now we can very clearly tell when we look at the theater and we look at the relationship movies and we follow the arrow. When we reach the end of it, we see, oh, there are two arrows there. So this is clearly a one-to-many relationship. If we go in the other direction, we eventually reach the arrow head there, and there's only one of them. So movies have only a 2-1 relationship, a not too many. So that's sort of the gist of how, at least you set up your models. So it's kind of it's nice. Like, so far we haven't really, as far as these things are concerned, we haven't written any code. But so the next step, and you don't necessarily have to do this, but if you actually need to access the code for these models, what you'll do is, so you can create a group. You don't have to create a group, but generally you'll create a group and say it's called models, and you can easily do that, right? Create, or click on there and add new group, and select that. And in this case, so say we want to do a select all, pretend that these other two aren't there, and you actually want to generate the code for these models. What you can do is go up to File, New File, and when those things are selected, what you should see is an option. This new thing comes up for this Managed Object class. And I think if things aren't properly, and let's check, if things aren't selected, I'm not sure if that comes up. So that could be, no, it does. I saw something in the documentation about that thing not necessarily showing up. So so we've got so we have our Cocoa Touch. Let me check that again, I'm curious. Okay. So grab these, new file, manage object class. You go next, and you'll say, where do you want to put these things? And you can sort of, I didn't need to select them. The fact that I selected them checked them off ahead of time for me. So from here, what we can then say is finish. And well, we can take a look down here at some things. Generate accessors, generate Objective-C properties. We want those checked off. Generate validation methods. I haven't looked into, but usually when you deal with models, you want to do something that, to make sure that the data that you try to put into them is actually valid data. So I suspect that this generate validation methods might be related to that. I haven't looked into it, but that's my guess. Because again, the model generally wants to try to protect itself and say, oh, you're trying to give me bad data. No, I won't let you give me bad data. So I'm going to cancel just because I've already generated those files, and we'll look at them in a second. And so the files it would end up creating, will look they'll look fairly familiar. Main thing is we're now inheriting off this NS managed object. And so we've got some properties, right? Our movie set up, we had a name for it, a description for it, and then the movie is playing in some particular theater. And if we look at the .m, there isn't very much that really, the main thing that's different that we may not have seen is usually we say synthesize name, and here we're saying @dynamic. And all this is basically a way to tell the compiler, hey, stop warning me about the fact that these setters and getters don't actually exist. Someone will supply them to you at runtime. And of course, if you don't, then there'll be problems. But if you do, then things are good. So if we take a look at the theater, same thing. It's an NS managed object. It's got the things that we put in there. So we said that the theater has a name, and maybe it tracks today's date. So a theater has movies associated with it, and the way that that's sort of taken care of is, movies are an NS set, so this unordered thing with all of our movies in it. And if we look down a little farther, we'll see another interface section. And you might remember this from one of the earlier lectures when we were sort of looking at Objective-C. I think I spent a bit of time talking about categories. So this is a way where, as a quick refresher, you can take an interface, like say theater, which was set up here, and in essence open it up and add additional methods to it. So this is sort of the syntax for doing that, and core data or this template took care of doing this. Generating these models from the entities took care of doing this stuff for us. And basically, so add movies, remove movies, add, they set up these methods for us. Another way of injecting methods into classes is through protocols. So protocols are a new, I think it's an Objective-C 2.0 feature. So prior to that, the things that you're doing with protocols now were generally done through these categories. So we look at the implementation. Again, not a whole lot going on. So behind the scenes, core data will be taking care of stuff for us. And again, dynamic, just telling the compiler, hey, don't complain that I haven't created these setters and getters. They'll be there at runtime. Okay, so any questions up to now? Yes?
When you create the new files for the models,
yes.
Would be that hard just getting splices from other vector files and using a couple of to like whether, for example?
So are you saying if you've now created these files, you want to go and mess with them and add additional things to them? So
Accessors to them that we have to get elsewhere, or
well, so that's where, so now you have so you have all the accessors, right? So the fact that we, when we save these files out, we clicked, generate the Objective-C properties. It put these things in place for us. Again, the main bit of magic is that usually we would say @synthesize, the name of the property, and that would actually, the compiler at that point would generate a setter and a getter for us. In this case, @dynamic is just saying that at runtime, when you use this, there will be a setter and a getter there for you, and that's sort of where core data will take care of that if your stuff happens to be, well, in this case, will be backed by some sort of core data store. What I don't know is, and again, this is just because I haven't played with this stuff enough yet, is, well, now I have this theater object, it feels scary because now what I could do is I can go in and start making changes here to this file. But if something happens and my model changes, I feel like, and I've actually written things in here and I haven't done them through, if I haven't done it through here, then you could end up like clobbering over some of your stuff. So that's something I haven't figured out yet because, again, I haven't used it enough. But in general, I'll say, as you're working with this, do everything, set up your models through that modeling tool. And let me make this go away. Okay. Yeah. Okay. So we saw how to put some of these together and connect them up. Next up, let's take a look at our root view controller. So so we have these objects, but how do we actually do anything with them? How do we get at them? And this is where there's an NS-fetched results controller that comes into play. And this is something I haven't had a chance to look at as closely as I would like to, but we'll go through it quickly, and then on Friday we'll finish up in more detail with it, and hopefully we'll have all our core data, at least the initial questions that we have about it, sort of in place. So at this point, this sample I don't think will run because I've made some changes and didn't make them in all, didn't update things in all the places that we need to. But the idea with this sample, if you just build it without any of the changes, what you'll see is a table comes up and you can add and delete rows in that table, and it just keeps timestamps of when that happened. So with that, to actually get at our data, again, so we have this fetch results controller, and we'll start at some of the things that table view, the methods that we need to handle, and we'll see how this fetch results controller sort of takes care of things for us. And we'll first look at it, how it's used, and then we'll see how it's set up. If we want to know, okay, how many rows, how many sections are in our table view, well, we ask our fetched results controller, we say, hey, get the sections and then give me the count. Okay, so fairly, I guess, straightforward for that. The other thing we'll generally need, so given a section, we'll say, well, how many rows are in that section? So again, we can grab, using our fetch results controller, we can get the sections and then say, give me some object at some index for that particular section. So now we have some objects associated with that section, and then we can just say, okay, given that section information, tell me how many objects are in there. So now we know how many sections we have. We know how many rows are in a particular section. The other one that's usually very important when dealing with table views is this cell for row at index path. So most of what you see here should be familiar from having worked with it at this point, but so the first thing is we want to grab a cell, and we want to reuse one, assuming that it was created ahead of time, or we've already created one. If it hasn't, then we'll go ahead and allocate it and set up whatever we need to set up for it. So we've got our cell. Next up now is so we want to actually do something with our little object. So we'll ask the fetched results controller for some particular object at some place, and this is easier than I think when we. Well, it's fairly similar to how we did it in, say, the RSS reader, but now it's just the fetch results controller. You just feed it this index path. You don't have to actually go in and grab anything out of it. And basically, it's saying, go off to this table and grab me some object in that table. So the example earlier, if we have this person entity and we're querying, somehow the row with my name comes up. This managed object will be a person object that has Shaban's name and social security number in it. And then from there, so we have our object. We can say, and this is where sort of that key value coding stuff comes in earlier. So, we can say, give me a value for key name. And I think the fact that we actually generated these files, the fact that we've actually generated these files and we have properties, we wouldn't necessarily have to use that value for key stuff, but again, just to see sort of how it's done. So we'll grab the name and the description, and we'll put that into the theater's table of movies. Okay, so that's sort of, here's this fetched results controller, this thing that helps us get stuff. Let's see how it's actually set up. Okay, so this one, again, I think very briefly I'll just say some of the things that the fetch results controller has associated with it, and then next time we'll start with the fetch results controller and look in greater detail into sort of this connection of, well, we now have our models, we have this fetch results controller, we'll look more deeply at, okay, here's how we actually, here's what it means to do all the things we do with it, and here's how to use it. But in general, from the stuff I remember, the fetch result controller, has a fetch request associated with it, and let's see. So then there's this entity description. So our entities are theater and movie. In this case, we just had event sitting here, but from the default thing that Xcode generated, but we would basically, this is where we could say NS entity description entity for name, and we could say theater, and it would give us, or we'd say movie, and it would give us a movie object, or at least a description for it. And okay, so fetch request. I guess we can, we can choose how large, how many things we want to fetch at a time. Just because you might have thousands of objects, you don't actually want to grab them all. With these, when you do a fetch, so actually, has everyone in here taken some sort of database course? I managed not to take one at UC Davis, so I'm curious. I didn't get to play with mumps or whatever it was that people used in that class. But so you're doing some sort of query on your database, and you're getting, you get back, your your rows of information. In this case for us, we'll get objects which represent those rows. The sort descriptor basically is a way of saying, hey, here's, sort based on some particular key or some particular attribute, and in this case, do we want these things to be ascending or descending? And the sort descriptor, I'm not quite sure. There's another one which is there's a predicate, which I'm not seeing in here, but you can get, the queries you make can be fairly, well, as complicated as you need them to be, or as intricate as you need them to be. So there's an NS predicate, which basically you can feed it these little regular expression type things to help pull your data in. So I think I'll just leave it at that for today. And on Friday we'll look more deeply into the fetch result controller, and maybe we'll try and finish this little example, which will be like, here's some movie theater and here's some movies associated with it, and let's actually do something. And there'll be another sort of recap of key value coding and key value observing, because that's very intimately connected to core data. And I think we'll look at the accelerometer. We probably won't spend too much time on it because I don't know how many people are using it for stuff. But we'll walk through some of the examples and see how to filter the accelerometer data using some low-pass filters and things. So, all right. Is core data slightly clearer for people now? A little bit? So? Okay. On Friday it will be very, very clear, I think. How many people are using it for their final projects? Okay. More people should use it. Because it's actually, it seems kind of weird at first, but I think, like, even as I'm learning it, I'm like, oh, okay. It's wacky, but I think once you get past a few of the kind of the setup things, it's very useful. So, okay. See you next time.